Okay, this is just wrapping up a little bit of 8.1. This is also, I'll go over the board stuff at the beginning of 12. But on Thursday, we're going to have an in-class quiz at the end of, whenever I give a quiz in class, it's always at the end of that class. That way, some people who finish quickly, you don't have to stick around and wait for everybody else. You're free to go. Same thing on a test. You're free to go as soon as the test is over. We're not going to lecture or do anything else that day. So we'll do it at the end. But I'm going to post something very similar to your quiz today, a quiz prep. Just 2 problems. And quizzes are open note. Open to everything and anything that's not limited to just a pre-run. So homework, the quiz prep that I'm going to post, I'll go over the quiz prep during the support class, just like right now. But basically, you're looking at something like this. They tell you what, the first quiz question is going to be find all the factors. Okay. So we're going to find all the factors of 72. I like to start with the number 1 and 72, and then just 2 words. 2 times 36 and just 3 words. 3 times 24, and then just 4 words. 15. Just 5 1. Is it in 0, 5? Nope. So 5 will work. How about 6? Since 2 and 3 both work, then 6 is going to work. So 6 times 12, the 7 work. I don't think so, because 7 would go into 72. How close? If you were dividing 7 into 72, how close could you be? 10. Almost. So how many times close can we get 7? 10, so 7, right? And then the next would be 77, so the 7 work? Nope. 8 work? Okay. So 8 times. And then the next would be 9 times 8, very happy. Okay. So in order, we got 1 and 2 and 3 and 4, skip 5 and 6 and 7 work. 8 and 9, and then we go to 12, and we go to, we just give 14, we go 9, 12, 18, 24, 36, and 72. And the last one's a word problem. How many sides does a rectangle have? 4 sides. What makes a rectangle special? What's that? Yeah, not necessarily. A rectangle is a parallelogram that has 4 blank. Blank blanks. Rectangle is a parallelogram, which means both pairs of opposite sides are parallel. And has 4 90-degree angles. So all 4 angles are 90 degrees. That's what makes a rectangle. Now you can have a rectangle that looks like this. That's horrible. And as long as I put the right angles in there, then you certainly are looking at a rectangle. You can have a rectangle that looks like this. But no, this is a rectangle. Even though it looks like a square. And you know what? Even if it was a square, the fact that it has 4 right angles means it's also a rectangle. All squares are rectangles. All squares are also rhombuses. But if you put a rectangle and a rhombus together, you get a square. And those are the properties. And that's also something we do in this class because we deal with geometry. Properties of the shapes. So, how many different rectangles can we make whose side lengths in centimeters? Do you think that's really relevant? Because when you're doing a word problem and you read this word salad of a whole bunch of stuff, a lot of it is just, who gives a damn? Don't say that when you teach. But a lot of it is, I don't give a damn. Whose side lengths are in centimeters are whole numbers, or whose side lengths in centimeters are whole numbers. So whole numbers are, basically whole numbers don't include what? Well, whole numbers include 0, but if one of the sides was 0, we wouldn't have any. So, but also don't include no negatives. But if we had a negative length, we wouldn't have a. I look to see that. You can't have a negative side. So whole numbers don't include the decimals or fractions. So whole numbers are just 0, 1, 2, 3, 4, 5, no, nothing in between. So you're not going to have 4.3. You're not going to have 4 and 1/2 or 4 and 1/4 or any of that. So how many different rectangles can be made whose side length in centimeters, a whole number, and the area is equal to 1,159 centimeters squared, or square centimeter. How do you calculate the area of a rectangle? Length times height, base times height, length times width. Yes, side times side. Side times side. So if this was a 3 and that was a 5, the area of this shape would be 15. If this was a 21 and that was a 30, then this would equal a 16, another 30, 630. Length times width, base times height. Well, we want to know how many different rectangles can be made if the area is 1,159 square centimeters, and we don't know the length of the width. We just basically have to figure out what times what are the factors of 1,159. That's all that you're being asked to do. What are the whole number factors or the nice numbers that go on to 159? So, first of all, it's not even so two. Well, the first answer would be 1 times 159. So, how many different rectangles? We have 1 centimeter by 1,159 centimeters. It's not even so two to them. Now, you're going to have to deal with it. I don't remember because everything just flows together year by year by year. Did I talk about divisibility rule? Like the rule for 3. A number is divisible by 3 if the sum of the digits is divisible by 3. So if these digits add up to something we can divide by 3, I can divide the whole thing by 3. So 1 plus 1, 2. 2 plus 5, 7. 7 plus 9, 7 plus 9, 16. So we add up to 16 is 16 divisible by 3. Because 3 goes to an either. So 3 does not go into 1,115. That's good. That means all the other possible numbers that 3 would go into won't work. The divisibility rule for 4. If the last 2 digits are divisible by 4, I can divide the whole number by 4. But you know what? I already tried 2. If it was divisible by 4, it would have to be even. So any even number is not going to work. 2, 4, 6, 8, 10, 12. No even number is going to work. So why bother even thinking? 5, it doesn't end in 5 or 0. Since 2 didn't work, 6 couldn't. And also 3 didn't work either. If 2 or 3, either one of them doesn't work, 6 is not. 7, we're going to have to check. So 7 into 1,159, 7 can't go into one of the thousand place. So you go to 100, we go 1 time, we get a 7. We subtract, we get a 9, we get a 5, 11 minus 7, that's a 4. 45 goes in 6 times, you have 42, subtract, and we get a 9, we get a 3, 7, so 7 doesn't work. 8's even, not going to work. 9 won't work because 3 didn't work. 10 didn't work. 10's not going to work. 11. I'm thinking no, but in the thousands place, 11 can't go into this one. In the hundredth place, 11 can go into the 11th. 1 time in the 100th place. That's 1100 from the 100th place. So when you subtract, you get 59. 59 in the 10th place, it doesn't go in at all. But 59 is going to go in 5 times, but I'm still going to have a remainder. So that didn't work. 12 won't work because it's even. Third. Oh, 13 does not go into the thousandth place. It's not going to go into the 100th place. So now I'm looking at the 10th place, 115. 13 can go into 115. So if I use 8 times 13, that's 80 plus 24, that's 104. Twenty-four times 2 is 104, and that would work. I'll get a 9, I get a 1, and I get a 1. and then a 119. Well, if I use 9 times 13, I would add another 13 to this. I get 117. It's not going to work. So 13, 14 is even. 15 is not going to work. I have 5 of them. 16 is not going to work. 17. Well, did I tell you can't use a calculator? How many would you have already given up already? What if you get to the pearly gates and you're trying to get into heaven and St. Peter says, oh, pass this math question. No calculator. Heaven would be empty. That, you know what? I think I'd rather go. I don't like word problems. That's what I wish was a math teacher. Then again, I probably wouldn't do it because I have a question. Find 17. So in the 1, note, in the 11, note, 115. So I'm thinking it's not going to be 8, maybe let's go with 5. 5 times this is going to be 50 plus a 30 is 85, so now 6, 42, and 60. Yeah. 17 times 6, we get a 2, with a 4, 102. Then we get a 9, we get a 3, we get a 1, 139. So 102 plus another second 119. I would have to make a 9. The only way I'm going to get 7 to make a 9 would be multiplied by 7. Multiplying by 8 would give me a 6. Not going to work. Multiplying by 9 would give me a 3. That's not going to work. And then that's the ones place that's not going to go at even. About 17, 18. Nope, it's even. 19. 15 into 1,100. So last time was 17 times 106. So 19 times 1 19 times 5. 9 times 5 is 95. 19 times 6 is going to be 60 plus 45. Oh, 60. 19 times 6 is going to be 114. Oh, look at this. How hard is this problem on a scale from 1 to 10? A common, huh? We'll see if you do this question. It's hard to say. Without a calculator. If you guys can participate, you will actively participate in your own education. I will show you something that will make your life so much easier. I'm going to need you to participate, not be passive. In other words, please, I need to know that I'm not alone in the room.
Sometimes I feel like I'm the only one here. I'm like being on vacation with a family.
So we knew it was 1 times 1,159. And we just got, what did I get? 19 times 19 times what? 61. 19. And I know that's done because those are prime. It's not going to break down anymore. Because if there were other numbers, then it would come out of the 61 and the 19. There'd be multiples or factors of those. 19 and 61 are prime. So it can't break that down. So you would basically go 1,159. And we know it's odd, so we're not going to divide by 2, but at least divide by 3, and it's a decimal. And then I'll try 4. We already know it doesn't work for 5. Don't try 6. Divide by 7. It doesn't work. But, well, actually, I don't do that. 1,159, divide by 7. It is not going to work. But I have even a better way. Minus this, if I go divide by 3, divide by the next one 7. Don't worry about 9. I try 11. Then we'll worry about 13, 17, about 19. Narrow. Now you even have to punch in 1,159 divided by 19. Because I was doing the same thing every time. So what I did was here where it says y equals, I typed in the equation 1,159 over x and the y1, y sub 1 equation. So that means there's an equation that is defined for 1,159 divided by any number I want to plug in for x. And then I went to the table and I said, okay, instead of having to do it over and over and over again, I went to the table and I just want to plug in the numbers I want to plug in, each one, instead of having to do it by hand. When I grade tests, let's say the test is out of 136 points. So what I'll do is 136 minus how many points you got wrong, how many points you lost. Then I'll do this. I'll go y bars function y sub 1 divided by 136. Enter. And then go into the table. And delete all those. So if somebody got, they missed 8 points on the test. So 136 minus 8, they got 128 out of 136, and their average is 94.1. So I don't have to do all of the calculation. I don't count how many they got wrong. If they got more, if they still, got all the extra credit, then they would have negative 10, say negative 6 points. So that means it would have been 136. So it's 136 minus X. So they're substituting 136 minus, I plugged in negative 6 points. So it's 136 plus 6. That's why this is 142, and they have 104.4%. Bobby says that 3 is a multiple of 6 because 3 is equal to 6 times the 1/2. In what way does Bobby have the right idea about the term multiple, about what the term multiple means, but in what way does he need to modify his idea? In other words, in what way is Bobby supposed to act?
Because a fraction is like.
It is division. When you multiply by a fraction, you divide it by 2. So 3 is a multiple of 6. Multiples are times whole numbers. The definition of a multiple is a whole number times the beginning number. So a multiple is bigger than the initial. Okay? Because there, if it wasn't, when we say least common multiple, well, there would be none because you could go infinitely down. Multiply by, instead of a half, multiply by a fourth. Multiply by an 8, multiply by 16, multiply by 1,024th. You could get infinitely small if they're multiples, and you would never have a least common multiple because you keep on going forever. So multiples are times a whole number, or technically times counting. Yes, it's multiplication, but it's not times a fraction. So I'm going to give you this one. So I'm going to send you this quiz prep for the quiz on Thursday. Find all the factors and do a work problem. And we'll go over this during the 11 part. We finished up 8.1. Move on to 8.2 at 12. And let's want to tell you about something. Oh, we got to. So I've been in touch with Pearson. And they told me too bad. They told me that students are no longer allowed to print anything, which I don't have a clue. I haven't responded. I have not sent a reply to their response, which was students are no longer able to print. Because my response is basically going to be students don't have time to just sit in front of a computer screen doing their homework. Students technically need to be able to print their homework, work somewhere else, and then come back and enter in their homework. I understand not printing quizzes, not printing tests, those kind of things. But not being able to print your homework doesn't make any sense. They talk about integrity and not assessment not being shared or something like that. I think it's just being lazy in there. I don't know. So I'm also going to say, this is if this is the way that it's gonna be with this textbook, then I'm gonna need to reevaluate who I work with. But I don't like it. It didn't change from my math 4P. My math 4P, those students can still print their home. But for 10A and 10B, deny it. Get it. So when you set aside your time, I'm trying to thin out the assignments. Trying to thin out the assignment. Now, doing preview odds and evens. Do you know the whole? I mean, it took me a while to understand growing up as a kid because we were, Rochambeau, rock, paper, scissors. I always understood that. I never understood when they would say odds versus evens. And they would do that 1, 2, 3, shoot. And you're supposed to put up a finger. They would do it really quick. So I never caught on watching it as a kid. What do you mean by odds versus evens? You're supposed to put either one, I think it's either one finger or no fingers. So when you go, so we're both going to put one finger, no fingers, like 1, 2, 3, shoot. And you're going to call it. So if you call odds, you win. Because 0 plus 1 is 1 odd number. But if you call even, I win. Because you call even, and that's an odd number. 0 plus 1, 0, 1, that's an odd number. But if you call even, it's like calling heads and tails. We don't have a point. They must have been really poor on those skills. And then this had too many possibilities. Rock, paper, scissors. You take forever. It's either odd or it's even. Binary. Yes or no. Now, comparison of odds and evens, and then divisibility rule 2. We're going to get into all the other divisibility rules, how to write it using variables. Then we want to start 8.3. All the other divisibility rules. And I'm going to give you the rule for 7. I just don't have it memorized. I've never given it before. It's crazy. The rule for 7 was just out. It's interesting. But there's a rule for 7, there's a rule for 11, there's a rule for 12. Well, 12 is just does 4 and 3 work. Says it was divisible by 4, divisible by 3, then it works. But there's a rule 13, there's a rule for 17. All these numbers have their own rules. But the question is it easier to actually try the 13 or to test for 13? And then you're going to need to know these. How can I make me learn the rule for 11, 13? But here's the craziest thing is that all these years of teaching, so many students that get to this level have never heard of these rules. They've never seen them. They've never heard of them. Nobody's ever taught to them. And if they had, they might be doing a lot better. But you look for greatest common factors, you look at the least common multiples, you know these rules for divisibility, life would have been a lot easier. Especially when it comes to simplifying fractions. Okay. So that was that big rule. It's like if you had to test this number for divisibility, what can you divide this one by? You could check by hand, does 2 work, does 3 work, and divide and check. Or you can use the rule. So we will get at least start through section 8.3 today. Let's come on back at noon. Everybody okay on Pearson? Got your Pearson on? Yeah.